So, hello everyone. My name is Alan. I'm here with Ermoon, and we're from the FarmSignal project. Our team members, as shown on the page, are Javier, myself, Armando, Stanley, Jonathan, and Ermoon. So, this is our outline for this presentation. We'll first talk about the problem, then we'll move on to talking about existing systems that solve this problem. Then we'll talk about our solution, the overview of how our system works. Then we'll get into the nitty gritty of the design and implementation. Then we'll wrap up with the live demo, and we'll talk about the results. And finally, we'll take any questions. So, problem. Frankly, we're not that great at taking care of plants. So, in true developer fashion, we decided to automate that process away. So, before actually deciding to automate this process, we did some market research, and some of the key characteristics that we found across several automated plant watering systems are that they usually tend to be expensive, difficult to use, not straightforward to assemble, and sometimes they also require extra tooling, such as soldering iron or 3D printed parts, which just um, isn't accessible for everyone. So, existing systems. So, one of the systems in our research that we came across is MIT's personal food computer. Essentially, the system is a contained box that finds and simulates the optimal environment for the plant to grow in. However, the problem with this is that it relied on several users to use this system to build up the database for the optimal growth environment. Um, and also their project scope was pretty huge, which eventually led to its failure. This um, this system was also quite expensive, around $2,000 in parts, and as you can see from the picture to the right, it's quite intricate and quite intimidating to set up for someone who's not experienced, and it also required 3D printed parts. The other system we found is the Smart IoT water sprinkler and monitoring system. This system uses an Arduino, um, and it also uses several sensors, such as an EC sensor, a pH sensor, and a soil moisture sensor. And an EC sensor just measures the electric capacitance of the soil. And it also only focused on one plant, specifically the chili plant. And it also wasn't user friendly, and not they didn't have a web application so the user can view their data. It was just hardware. So our solution was to create an automated plant watering system with a focus on ease of use and accessibility. And some of the characteristics for our system, or some of the criteria that our system must meet, are that it has to be affordable. Um, it must not require any special tooling, such as 3D printing or soldering. It must also The hardware parts chosen must also be extensible to allow for expansion down the line in case we want to add extra sensors and stuff. Um, we must also create video and text documentation to make the assembly process and installation as easy as possible for the end user. And finally, to make our system open source and free and available for everyone or anyone to use. So, so what does FarmSignal actually do? Our system right now, as it stands, it monitors the soil moisture sensor. It monitors the soil moisture using a soil moisture sensor, and it waters the plant accordingly. So if it falls below a certain threshold that the user specified, it'll start watering the plant, and after a certain point, after it reaches the high end threshold, it'll stop watering the plant. Um, it also monitors and records the ambient temperature and humidity the of the room the plant is in. All of this data is collected by a Raspberry Pi, and this Raspberry Pi then sends that data to a server, and the user is able to view all of that data on a web application. And it also, of course, sends the user an email notification about their plant. So this is a high-level overview of how the system works. To the left side is more of the hardware and plant, and to the right side is more of the web application and how that works. So here you can see at the heart of it, we have a Raspberry Pi. That Raspberry Pi then determines essentially every 10 minutes, I believe, if the soil moisture sensor is under a certain threshold, it'll start watering the plant. It'll collect all that data through those sensors. Those sensors then get sent to the backend of our AWS server. And then that data gets stored, gets sent to the front end, and then the user can see that data. This is all of the hardware that we ended up using to make this project possible. On the left side, you have an overview of all of the hardware systems, and on the right side, you have all of the hardware connected and assembled. So now I'll go ahead and pass it over to Ramun to talk about the backend.
Hi, so I'm going to talk about the backend. So our web server is actually live right now. You can actually visit it if you go to farmsignal.net. So our backend, we built it on an Amazon EC2 private virtual server instance, and it's running Ubuntu. For the database, we're using MySQL. We decided to use MySQL since it's a relational data structure, and it aligns well with the information that's going to be stored. For the web server, it's using Node and Express. We have 3 Express server instances running. We have one running on port 80 for HTTP connections, another one running on port 443 for HTTPS connections, and then we're using port 8080 for API requests. For any connections that are done through port 80, we're actually redirecting it to port 443 since it's more secure with the SSL certificate. The web API routes are built to get data from the database and return as a JSON. And it's also able to add and update data in the database as well. Next slide. So this is our MySQL database schema. As you can see here, we have 4 tables. We have the account information table, which holds information about the user's account. We have the plant info table, which holds information about the plant. And then on the right side, we have the plant data table, which is the information that's going to be sent from the Raspberry Pi. On the left side, we have the plant images table, which stores the path for the plant image. And then all these tables are linked through foreign keys. So I do want to talk a bit more about the web API. The web API also handles authentication through a login API request. And for the user credentials, we're using bcrypt to securely hash the password. It also generates a salt and encodes it as part of the hash, and this helps prevent rainbow table attacks. We also have an SSL certificate to make sure that traffic to the website is encrypted. And to save user sessions, we're using JSON web tokens. So the user only needs to log in once, and they're able to visit all the other web pages without having to log in again. We also have image hosting, so the user can store images to the web server, and then once it's stored, they can retrieve it, and it's displayed in the front end. The backend also has an email handler that's used for password recovery and notifications. And for this, we're using NodeMailer and Gmail for the emails. And then I'll go ahead and pass it back to Alan to talk about the front end.
Okay, thanks, Sirmun. So now, I'll go ahead and talk about the front end. So for the front end side of things, we decided to use React. And React, if you're not familiar with it, it's just a JavaScript library for building UI components. However, we noted that building components from scratch was quite time consuming. So we decided to use another library called Material UI, specifically for React components. So using this Material UI library, we're able to select and choose components that we find that fit our application well. And we also decided to use some other node packages to go along with our application. Um, so the first package is the React Liquid Gauge package. Essentially, this is just used as a percentage gauge for soil moisture sensor. Um, the next package is the React Chart.js, which is a wrapper React component for the Chart.js library. And the Chart.js library is just a library that allows you to use charts and graphs easily. And we use this for the temperature and humidity charts. Finally, we used another wrapper library for Formic using Material UI, and this just makes processing and handling forms much easier. So our documentation. So we have both text and video documentation available now through those links. If you use any of these links, they redirect you to our actual documentation. So our text documentation is available at farmsignal.net or docs.farmsignal.net. Our video documentation is available at videos.farmsignal.net. And if you just want general more info about this project, you can go over to info.farmsignal.net. And with that, we'll go ahead and start the live demo and hardware video presentation. So before we dive into the demo, I just want to mention the websites again. So this is our documentation page. This is our videos page that walks the user through how to assemble our system. And this is the info.farmsignal.net page, which just gives general overview of our system, what it does if you want to learn more about it. So with that, let's go ahead and start the video. So at the beginning, the user will have to load up a terminal application. They'll, of course, have to log in. After they've logged in, they'll have to select the plant that they want their Pi to send data to. After they select their plant, they'll have to start a calibration sequence. As you can see to the right, I'm currently calibrating the soil sensor. Now I'm calibrating it for wet soil reading, which just takes a reading for whenever the soil is wet. And now finally, we're placing it inside of the plant to take the current soil moisture. And as you can see at the bottom right, we have a little LCD page or LCD screen that just tells the user what's going on. And finally, you can see at the left side, the data got sent successfully. So when we refresh the page on the right side, it gets sent. You can see all the data there. And yeah, that's it for the video. We can hop over to the actual web page. So in the web page, we can, of course, log in or sign up. I already have an account made, so we'll just go ahead and log in. And the page that you saw, or the plant that you saw in the video is this one, my plant. But for this presentation, we'll be talking about Jimmy. So Jimmy is the plant that we've used for testing. As you can see here, our current soil percentage is 62%. Right now, it's not connected, but we did have it running for like a week or so. And this is our current temperature. So we can filter these two graphs by alt time and most recent. Most recent is the default graph state. So it just grabs the first five the five most recent readings from the Pi. And then we can also graph it by alt time. And as you can see here, it's a more zoomed out view of all the data points collected over time. Here is the same page, the same data, just in text format. So we can see here our plant name, plant species, raw soil capacitance, temperature, humidity. We can also edit the settings for this particular plant. We can turn off or on notifications. We can update the name of the plant, and we can also update the species, and we can delete it. And we can also go ahead and upload a new image. So I'll go ahead and do that now just to demonstrate. So we'll just use this image, go ahead and update it. And as you can see, it gets updated. And we also have, the user is also able to add a plant, delete a plant, edit the settings about their account, or log out. So we'll go ahead and walk through each of those pages now. So this is what the add plant page looks like. We can add a plant called test, confirm. We can upload an image. So I'll just upload this image for now. Go ahead and confirm. Plant was added successfully. Great. So if we go back to the home page, you can see our test plant has been added. We can also go ahead and delete a plant. Here we delete a plant. Next, we can go over to the settings page. Here in the settings page, we can update our current email or our current username that we use to log in, our password, and finally, we can go ahead and log out. So with that, that completes our demo. So we'll go back to the presentation. So what did the development process for FarmSignal look like? So we used the agile development methodology. So when this methodology, our sprints lasted about a week. We also utilized Jira, and we use Jira more as a Kanban board for tasks or tickets that needed to be completed by the end of the week. And a Kanban board, if you're not familiar, as you can see at the image towards the bottom of the screen, right here. Essentially, each column defines the state of a certain task. So you can see order received. This isn't the Kanban board we actually use. This is just an example. But each column has a state, and tasks have they go within those columns to define the order they're in. So if something still needed to get done, we knew what everyone was working on and stuff. And we also had Scrum meetings, and these Scrum meetings were every Monday and Wednesday. And during these meetings, we discussed our progress, our roadblocks, and things we plan to work on. And this is the development team. So for the majority of the development process, we split off into two teams, the front end and the back end. I was the lead for the front end, and Ermun was the lead for the back end. So finally, we'll talk about our results. So we found that small to medium houseplants work best with our system. Our automated plant system is also affordable, easy to use, and accessible compared to other systems on the market. Our current price comes out to be around 175. However, it should be noted that the pricing is for each individual component. However, this pricing can be lowered if you buy kits that are sold on Amazon regularly. If you do buy a kit, this price lowers down to more like around 140. And finally, our application was deemed easy to use and intuitive by friends, family, and colleagues. So our future work. So currently, our system is only able to monitor one plant. However, the hardware we chose allows us to extend it, so we're able to support more than one plant. And the current hardware, with the current hardware, we're able to support 9 plants if we continue to work on this and decide to implement this functionality. Also, as you saw from the video, our system, when it calibrates, it does so through a terminal application, and that usually isn't the best for a non-experienced user who isn't familiar with the terminal. So to counteract that, we can create a GUI application for the calibration and the setup. We can also add support for older Pi versions, such as the original Pi, the Pi 2, and even the Pi 3. Our system right now only works with it's only been tested on the Pi 4. So if you were to use a Pi 3 or a Pi 2, it may or may not work. That has not been tested. Uh, and finally, we can also create an offline version of the FarmSignal web app. So that way the user doesn't have to rely on an internet connection and will just be able to view the data about their plant without an internet connection. And finally, for acknowledgements, we would just like to thank CSUN associate students for the funding of this project. With that, we'll go ahead and take any questions that you guys have.
That was a very thorough presentation. Thank you for walking us through that. Good view on the software development, and I guess your hardware integration there with the sensors that you're using. I was just wondering, as far as the watering, I mean, are there any sort of like customizable set points, or you didn't talk about it too much, but what's the threshold for it needing to be watered or not? Do you set a humidity value or a moisture value?
Yeah, that's a great question, actually. So right now, the way our system works is that if the soil percentage is less than 20%, it'll start watering. And it'll keep on watering until it reaches a threshold of 70%. At that point, once it reaches 70%, it'll stop watering. Um, and that's a feature we try to finish implementing by the end of this week, but we weren't able to get that done.
Understood. So it's so similar to like an HVAC system. There, you would choose that target, and then you would reach a particular threshold, and then it would stop watering at that
Yeah,
point.
exactly. Correct.
Okay. And then any thoughts? And I like that you actually talked about it scaling to like up to 9 plants. Is it really just for plant applications that are mostly indoor based? Obviously, it looks like your design requires you to be next to an electrical source. Have you guys thought about doing something that's a little more remote and wireless, where there's a battery and the sensor part of it?
Yeah, we have thought about that, but since we wanted to minimize cost, we found this to be the best solution um, that takes into consideration the cost of how much the user is willing to probably spend on a system like this.
Right.
But yeah, in order to keep costs down, we decided to go with a wired sensors and stuff. But yeah, definitely towards the future, if we decide to continue with this, we definitely look into keeping things wireless, so that way your plant isn't as close to the FarmSignal system.
Right. And then with the data that you're providing, you talked about MySQL and a bunch of data that you're providing to the user. Is it just for observation, or does it do trending? What was the thought process with regard to that?
Sorry, you cut out there. Could you repeat the question?
In your presentation, you showed that you were collecting data and you were utilizing tools like MySQL, and you were showing some averages and some statistical data. Was that just for observation from a user point of view, or were you going to build on that in the future to have other features?
Yeah, great question. So unfortunately, we didn't have enough time to actually consider thinking about like adding trending data points and stuff, but that would definitely be something we would look into the future. But as it stands right now, the data that gets presented to the user in the web application is just there to inform the user about the current ambient temperature, to make sure that their plant is on track to grow.
Thank you.
Yes, thank you for those questions. I was also kind of curious about if you'd had any experience prior to this in working with hardware and software combinations. one thing, web pages, when you're just dealing with data, it's very different than you're dealing with hardware interactions. Can you comment on that?
Yeah, great question, actually. So initially, before we even thought about FarmSignal and before this FarmSignal was even an idea, a year ago during summer of last year, I decided, I realized, hey, I suck at taking care of plants. So why don't I try to automate this? And so I spent that whole summer trying to figure stuff out with the hardware and the software. And that helped tremendously during the development of this FarmSignal.
Great, thanks. Yeah, I have to say it is a lot. Moving forward is a lot of tinkering and playing to see how the components interact. Nice job. Thank you for that.
Thank you.